Hello everyone, this is Mrs. Taylor. I am one of the Algebra 1 and Geometry teachers here at NDCL. Maybe if you were in Algebra 1 last year, you recognize me, maybe you even had me in class. Some of you are incoming freshmen going straight into geometry. To those of you, congratulations. I hope that you will love your time here at NDCL. So what we're doing is a couple of videos and a couple of short quizzes that you need to pass before school starts in August. That sounds kind of ominous. However, these videos will be relatively short and straightforward, and the quizzes are relatively short and straightforward as well. If you watch the videos, pay attention, take a couple of notes, work a couple of examples with me, when it comes time to do the quiz, you won't have any problem whatsoever. And keep in mind, you can take the quizzes over and over again until you pass them. So there's not a whole lot of pressure to do great the first time. These will count towards your grade come fall, so it is 100% necessary that you go ahead and do these quizzes. Also, it'll set you up for success as you go into geometry this year. The 4 videos that we're doing are meant to reinforce some of the Algebra 1 concepts that we feel are important that you not forget. And some of these are actually going prior to Algebra 1 all the way back to your middle school and in some cases elementary school years. For instance, I think most of you touched on fractions going back into elementary school. And certainly you learned words like sum, difference, product, and quotient in elementary school. And in case you forget what those mean, because we don't tend to use them all that often, but you will see in this quiz that you're asked to find the quotient of or find the product of, and I want to make certain that you understand what those words mean. So sum means addition, difference will mean subtraction, product means that you need to multiply 2 things together, and quotient means that you'll be dividing things. Also, throughout the video, I'll be using precise mathematical language. And so when I refer to a numerator, you need to remember that that's the number on the top part of the fraction. And when I talk about the denominator, you need to know that that's the number on the bottom of the fraction. Also, we will need to know the phrases mixed number and improper fraction. So a mixed number is a whole number and a fraction together, like 2 3/4, and the improper fraction is taking that same number and converting it into just fractional units. And when you do this, an improper fraction, the numerator will be larger than the denominator. So hopefully you remember how to convert this. And basically you take the denominator and you multiply that by the whole number. So 4 times 2, and then to that number you add the numerator. So 4 times 2 is 8 plus 3 equals 11, and then you take that and you put it down over top of the original denominator, and that gives us our improper fraction. So let's go ahead and get started. When we add fractions, we need to have a common denominator. So in this particular case, we're good to go. It's really easy. 8 is already my denominator for both fractions. So I'm going to say 3 plus 7, and I'm going to put that over 8. 3 plus 7 equals 10, right? So it's going to be 10 over 8. Notice how I'm lining up my equal signs straight down. Neatness matters in mathematics. And then I need to look at that and reduce it. And one of the things that immediately crosses my mind is both 10 and 8 are divisible by 2. So I can say 10 is the same as 5 times 2, and 8 is the same as 4 times 2. At that point, I can divide out a 2 from both of these fractions, the numerator and the denominator, and my final answer is 5 over 4. Now, hopefully, you don't have to go through this step. You just recognize that 10 over 8 is equal to 5 over 4. But there will be more complicated examples where you might need to do that intermediary step in order to figure out how to reduce the problem. So our correct answer for this is 5 over 4. So let's move on to this next one. So I've got 3 over 4 plus 3 over 8. I have a common numerator, but that doesn't mean anything. I need to have a common denominator. And in order to get a common denominator, I need to figure out how to manipulate one or both of these fractions so that I have the same number in the denominator on both. And I look at 4 and I go, well, the one thing I know about 4 is that 2 times 4 equals 8. So what can I do to make 3/4 some fraction where it's over 8? Well, I can't, remember, this is algebra, so I can't do anything to one side of the equal sign that I'm not doing to the other. And right now I don't have anything on the other side of the equal sign. I'm trying to figure out what goes on the other side of the equal sign. So I can do something to 3 over 4 to make it over 8. Well, 4 times 2 gives me 8. But I can't change the value of 3 over 4. So what if I multiply 3 over 4 by 2 over 2? 2 divided by 2 is 1. I have not changed the value of anything. I'm just going to change the way it looks. So now I'm going to say 2 over 2 times 3 over 4. Well, when we're dealing with fractions, we multiply straight across the top and we multiply straight across the bottom. So now I'm going to end up with 6 over 8 plus 3 over 8. Now I've got a common denominator, and I'm going to add straight across the top and keep my denominator. So my denominator is now 8, and on top I have 6 plus 3. 6 plus 3 is 9, so my final answer is 9 over 8. Now, 9 is odd and divisible by 3 and 1 and 9, and 8 is even and divisible by 1, 2, 4, and 8. Aside from the number 1, there's nothing that divides evenly into both of those numbers. My fraction is in its most reduced state. So my final answer for this is 9 over 8. All right, let's move on to this one. And this is getting hairy, because on the last one, I was able to see relatively easily that 4 and 8 had a lowest common denominator of 8. But when I look at 8 and 11, I go, I don't think there's much I can do with this other than to multiply these two numbers together. So let's see, I'm going to double 8. I'm going to come off to the side and say 8 times 2 is 16. That's not divisible by 11. 8 times 3 is 24. That's not divisible by 11. 8 times 4 is 32, not divisible by 11. 8 times 5, not divisible by 11. 8 times 6. So I'm going to keep doing this, and ultimately I don't get anything that's divisible by both 8 and 11 until I multiply 8 and 11 by each other and get to 88. So my lowest common denominator has to be 88. Okay, how do I get to 88? I'm going to rewrite this and space it out a little bit differently so I have a little bit more working room. So I need to figure out what I can multiply 3 over 8 by in order to get a denominator of 88. Well, 11. So I'm going to multiply 3 over 8. I need to multiply the denominator by 11 to get to 88, which means I also need to multiply the numerator by 11, because 11 divided by 11 is 1. I'm not changing the value of this fraction, I'm just changing the way it looks. All right, so that gives us, I multiply straight across the top, I multiply straight across the bottom. 11 times 3 is 33. 11 times 8 is 88. Okay, we're good to go there. Let's start working on 4 over 11. So now I need to figure out what I'm going to multiply 4 over 11 by in order to get the denominator to be 88. Well, I'm going to multiply that by 8. So I'm going to multiply the denominator by 8. If I multiply the denominator by 8, I have to multiply the numerator by 8. 8 divided by 8, 8 over 8 equals 1. I'm not changing the value, I'm only changing the way it looks. When I multiply fractions, I multiply straight across the top and I multiply straight across the bottom. 8 times 4 is 32. 8 times 11 is 88. So I've got now two fractions that both have the same denominator of 88. So now I need to add straight across the top 33 plus 32 and put that over my new common denominator, which is 88. I'm going to add 33 and 32. That gives me 65 over 88. Now, I need to make certain that my fraction can't be reduced. And so I need to think about what numbers go into 88. And so 88 is, well, we said it was 8 and 11. And this can be broken down into 2 times 4 And that can be broken down into 2 times 2. So 88 is 2 to the third power times 11. Let's think about 65. So 65, well, 5 goes into 65. 5 goes into 65 13 times, and both 5 and 13 are prime numbers, which means that I can't reduce this fraction. There's nothing that these two things have in common. When I look at this and this, there's nothing in common, which means this is the final answer for this problem. So 65 over 88. All right, let's take a look at this last one. This one isn't so difficult in terms of finding a common denominator. Clearly, I look at 5 and go, well, I know that 5 times 3 gives me 15. So I'm going to come over here and say, in order to get a common denominator, I'm going to multiply the bottom by 3. And if I multiply the bottom by 3, I have to multiply the top by 3. 3 over 3 is 1. I'm not changing the value of the fraction. I'm just changing the way it looks. So now I've changed this. I multiply for fractions. I multiply straight across the top. I multiply straight across the bottom. So I'm going to end up with 3x over 15 plus 2 over 15 equals, and now all I have to do is add straight across the top and put it over my new common denominator, which is 15. Well, 3x plus 2. And folks, I realize we don't like the way this looks, but for right now, that is my final answer. It will very rarely be a final answer in applied mathematics. If you have a word problem, you probably won't have that as an answer. But sometimes when we're learning how to do other things, we will have this as an answer. So 3x plus 2 divided by 15 or over 15 is my final answer for this. All right, subtraction is just like addition. We need to have a common denominator, and then from there, we're going to subtract just like we would in real life and put it over my common denominator. But not only do I not have a common denominator, I have a mixed number that I have to deal with. So in the beginning, I said that to deal with a mixed number and make it into an improper fraction, I needed to multiply the denominator by the whole number and then add the numerator and put that answer over the original denominator. So let's see, this should look more like a 7. 8 times 1, I'm going to bring this down real quick. 8 times 1 is 8. 8 plus 7 is 15. So this fraction becomes 15 over 8 minus 5 over 7. All right, so the lowest number that both 8 and 7 go into is 56. So there's going to be a couple of strategies. You may be able to look at fractions and say they already have a common denominator, in which case you're good to go. You may have a situation where you just need to figure out how many times one number goes into the other. And then once you figure that out, you just multiply the one number by whatever that is by the other. We did that with this one where we just needed to manipulate this x over 5 to get it to be over 15. In this particular case, it's going to be more like one of our other examples where we need to multiply both fractions. So what I'm going to do is rewrite this with a little bit more space. And we said that our common denominator was going to be 56. Our lowest common denominator is 56, and 56 is 7 times 8. That's how we got that. So I'm going to come over here and say, well, in order to get the denominator for this fraction to be 56, I need to multiply the denominator by 7. And if I multiply the denominator by 7, I have to multiply the numerator by 7. And for this fraction, in order to make the denominator become 56, I need to multiply it by 8. And if I multiply the denominator by 8, I need to multiply the numerator by 8. So now I say 7 times 15. And folks, I don't know what the answer to that is off the top of my head, so I'm going to come over here, carry 3, 7, so that's 105. So this becomes 105 over 56. All right, and then I'm going to multiply straight across the top and straight across the bottom for this one as well. 8 times 5 is 40, and 8 times 7 is 56. So now I just need to do that subtraction. So I make it one fraction where I have 105 minus 40 over 56. And I need to do some subtraction. So that would be 65 over 56. And again, I need to think about, can I reduce this fraction? My last step is always going to be, can I reduce this? So I think about 65. And I say 65, we already figured out that this is 5 times 13, and those are prime numbers. And I know that neither 5 nor 13 goes into 56. And I know this because when I do my factor tree for 56, I get, well, 7 times 8, and 8 can be broken down into 2 and 4, and 4 can be broken down into 2 and 2. So there is nothing that this has in common with this, right? Because there are no common factors for those two red circles, my fraction is in its lowest reduced state. All right, let's find the product. Well, this should be easy because we've been multiplying fractions for 2 slides now. When I multiply fractions, I multiply straight across the top and I multiply straight across the bottom. So 7 times 4 is 28, and 11 times 5 is 55. And I might need to ask myself, can I reduce that? So I might need to come over to the side and jot down 28 is 7 times 4, and 4 breaks down to 2 times 2. So that's my prime factorization for 28. And 55 has a prime factorization of 5 times 11. There is nothing here that is also common to there. Therefore, this answer is my lowest, most reduced fraction. Okay, so that's how we multiply, straight across the top times straight across the bottom. I want to take a look at this one and tell you that there are 2 ways to do this, and it doesn't matter to anyone which way you do. You can do straight across the top times straight across the bottom. 6 times 8 is 48. 7 times 3 is 21. But then you need to ask yourself, is this the lowest, most reduced version of this fraction? So I'm going to come over here and think about 48. 48 is 6 times 8, and that breaks down to 2 times 3, and this is 4 times 2, and that breaks down to 2 times 2. So here's my prime factorization for 48. Now I'm going to do the same thing for 21. 21 is 3 times 7. 7 and 3 are both prime numbers. I'm finished. Well, the one thing that I notice is that 3 and that 3. So now I need to figure out how to do this. So I say, all right, 1, 2, 3, 4, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So 48 is equal to 3 times 16, and 21 is equal to 3 times 7. Do I write all this stuff down? No, this is so you can see my thought process. So I'm going to rewrite this fraction as 48 is 3 times 16, and 21 is 3 times 7. I've got a 3 on the top, I've got a 3 on the bottom. I'm going to divide both of those out. And that means that my final answer is 16 over 7. That is my reduced fraction. All right, so that's that for that. The last thing that we need to do is divide. And when we divide fractions, we're going to flip it and multiply is the phrase that we use. So let's talk about 16 divided by 1/4. So that is 16 divided by 1/4. You might also see that written as 16 over 1/4. Okay, so the divided by, this is the thing that we're going to flip in either case. Okay, so we're going to end up with 16 times, that's the multiply, by 4 over 1. All right, how do I multiply a whole number by a fraction? Well, I can do this two ways. I can do this and then multiply straight across the top and straight across the bottom. Or I can recognize that 4 over 1 is actually the same thing as just 4. And then this is just regular old multiplication. 16 times 4 is 64 over 1. So my answer for this problem is 64. So we flip the denominator or the thing that we're dividing by and then multiply it by the numerator. So for this one, we have 5/12 divided by 5 over 6. We might see this written as 5/12 divided by 5/6. So we're going to flip the divider by and then multiply it by the numerator. So I'm going to say this is the same thing as, this is equal to 5 over 12 times 6 over 5. So I can do this two ways. I think I started to say this on the last slide and then I didn't actually do it. So the last time I multiplied straight across the top and I multiplied straight across the bottom, but I can also say this. And I've got 5 on the top and 5 on the bottom. I can go ahead and divide that out and say that this is the same thing as 6 over 12. And hopefully you say, but Mrs. Taylor, 6 over 12 is 1/2. And there we go. Now, some people will skip this step altogether. And they'll say, well, I've got this 5 and this 5. They're going to cancel each other out, because in that next step, I would divide it out of both the top and the bottom. And you might even say, I can also take 6 and 12 and cancel those out because 6 goes into 12 2 times. So now I've got a 1 here, a 1 here, and a 1 here. I'm going to multiply straight across the top. 1 times 1 equals 1. And in the bottom, 2 times 1 gives me 2. So you have a couple of different ways to approach these different things. So that's it for the first video. If you need to go back and write down a couple of things, you're more than welcome to, but head on over to Blackboard and take that quiz. Good luck with that.